Okay, good evening.
Good evening, sir.
Still only 19 students here. Okay, 20. Um, well, I'll go ahead and start. Others can join on. Only 30 students. Yeah. Okay, so uh, I think uh, yeah. So welcome to the automotive engine section, session number 2. So with today's session, we only have like a very small section to complete in the next day. After that, we will be finishing this whole topic, automotive engines. Okay, so I hope that you already have gone through the last week's lectures and gone through the questions, and I have provided a lot of additional links that were related to related to topics that we were discussing. So I hope you had enough time to go through them and get or gather more information about those things, because today around 9 o'clock, as I promised you last week, I'm planning to open your quiz session. So today at 9 o'clock night, 9 o'clock quiz will be open, and it will be finished tomorrow 12 o'clock night, right? So you have like around full day to complete the quiz session. I will discuss about the quiz session later, but one more important thing, there are some students who do not actually have the access for LMS. There are some LMS issues going on. I think they forgot their passwords, usernames, or something like that. So for them, so considering about them as well as the others, only I decided to give like a little bit more time, so the guys who do not have the LMS accounts can they can actually complete the um, quiz and send it to me through email. Um, yeah. Before we go into the lectures, I need to inform you one thing. When you are sending answers, answer script or something like that, related to your module, right? Related to any module, don't like type Simon's on something something in the topics. If you are sending it through email, so what you should type is uh, type the course code. So in this case, ETA 212 TC1 assignment, then keep a space and assignment number, right? So that means uh, ET in last week's or the previous assignments. So you have completed assignment number 1, and today 4 o'clock is the today 4 o'clock is the due date and the last or due time for submissions. When you submitting it, you have to submit uh, when you are actually sending it through email, you have to say like ETA 212 TC1 space then assignment 1, right? That's enough for your title. I don't put anything in the email, so because otherwise I have to manually filter out the each and every each and every answer script you have sent. So please make note of this and make sure to do that way. I will put a note in the LMS also, so you can actually see this well. Okay, so automotive engines, we have discussed how to take the engines, dismantling. Up to dismantling, we have discussed, and the only part we have remaining from this session is for you guys to actually go ahead and completely dismantle the engines from what you have learned. So since we are actually conducting this in sort of like a long distance learning situation, uh, that step is only, or that step will be happening after we open our university, or at least after the government cleared for people to move about. So after that, we'll come up with some solution and come up with some idea, some solution, and I will actually inform you. Until then, I can't actually say what to do. So I am actually planning for two options. One is So as usual, so that means after we finish all the lectures or all the discussion sections over here, right? Then you guys, then when we are starting the university or when we were opening the university for the students, let you guys to come and complete the 2 weeks or something quarantine or something. Usually that will happen at the moment. If you go ahead and you will be quarantined. So after that quarantine, put like 1 or 2 weeks, completely do the assembling, disassembling, and that part of the whole module. Okay. Or that's the choice number one. And second choice is if we were not clear to open anytime soon, if it is possible also to bring like a set of students like 10 students, I don't think 10, around 6 or 7 students per group. We bring one group and we start their practical. While they are finishing up the practical, another group is coming and they are staying in the quarantine. We first finish the first group and send them home. Next, we take the second group and finish and send them home. That's another option that I'm actually, not we, I am actually considering. But I'm still like, I can't give an answer because I don't have any control over any of the things happening nowadays. So until these things clarify, sit tight, I will inform what's going to happen. So until then, we'll discuss through these online sessions, and I believe YouTube is a very great help at this moment and a great resource at this moment. So uh, try to use as much as possible YouTube. There are so many important uh, sessions there. You can use them, and there are some other learning sort of uh, learning oriented video services or streaming services, which will actually unfortunately cost a little bit higher. Okay, voice is lagging. Network problems. Okay, just wait. I may be able to fix that. Give me 1 second. Okay, I checked a little bit. I think it's okay now. Let's see. Yeah. So today, what are we going to discuss? Up to now, from this whole module, we have discussed up to the removing of the engine from the vehicle, dismantling section. So dismantling section means I gave you some information and I shared you some videos. So I believe you have gone through them. I will be checking on whether you have gone through on them or not, but not this instant. I will ask some questions and hopefully you will be able to answer. So today what we concern is inspecting the engines, parameter testing. So in the parameter testing, we are considering about coolant system pressure testing, engine compression testing. So these are the two things we're going to discuss, and finally we are going to actually go ahead and look into the engine overhauling section. So here parameter testing session or this section, these parameter testings will be, you will be actually doing them later on in your courses. We do not actually perform these tests in this particular practical because there are some other modules very much related to these testings and these sort of the applications of these testing. So you will be performing these testings later on, but I'm just giving you a small introduction about this testing. And I have some I found some YouTube videos you can actually go ahead and watch and see how the testing is actually going on. In addition to that, I expect to discuss about the engine overhauling. So I'm planning to give you like a not an in-depth. I'm not going to teach engine overhauling in depth, but I can give you like a outline of the engine overhauling process and what's happening in the engine overhauling process. So we'll discuss those sections now. Okay, so as usual, safety first. Okay, so the first thing when you see any engine or any components, to back to the matter, is any components, first thing you have to do a visual inspection. Visual inspection is very important because sometimes if you didn't do a proper visual inspection, if you try to dismantle it, you could damage the components because there might be some very small cracks that you didn't notice before, but when you are trying to loosen it, it may actually cause damage. So in such cases, you actually have to take precautions to not to increase the damage already in the component. For example, sometimes heating actually helps. So basically, there are a few things you actually need to look after. So one thing is leaks. If any oil leaks, if any fluid are leaking from any of the engine components or any engine or any components or engine, you actually have to trace and find out what is the leaking components and note that, because that leaking components could be the reason for a catastrophic issue in the engine. I will actually explain this one further further back in the presentation. So cracks, if there's any small cracks, heat related stress issues or heat related or stress related issues. For example, in some vehicles there are possibilities of breaking the bell housing bolts or bell housing sections. So bell housing section. So that's more related to the stress issue. Sometimes heat related issues are also cracks and sort of things are coming in the engine head. So you have to make sure give a very good visual inspection. But some things you can't actually properly see them later. Loose components, for example, uh, due to vibrations, sometimes the engine components become loose, and any abnormalities, right? Any abnormalities, if you can see any abnormal gunk or something in the engine block or somewhere, you have to make sure, you have to check it further and examine it and identify it, and before you go further into the breaking down the engine. These are very important section, even though it seems like it's not important. These could actually give you an idea why, for reasons for an engine to actually fail. Okay, for example, yeah, one example is so I'm talking about abnormalities. So assume that give me so assume this is your engine block, right? And there's a small crack, and oil is coming, very small amount of oil is coming from the crack because of the vehicle driving in the dirt and everything. This crack could the oil could actually attract the dirt, and it could actually remain here, and later on this become a big sort of like a gunk here, but you never consider why you start dismantling everything. But if you properly, and let's say the engine failed, and you have no idea why the engine failed, but the reason for engine fail could be actually this crack could actually send the engine oil, and later end up being a bigger crack, and somehow engine does not have enough engine oil inside it, so because of that it started to wear out. So that sort of thing could have happened. So because of that, make sure to uh, inspect everything visually first. So another few things we can use to understand about engine conditions and what sort of issues happening inside the engine, or what is the problem inside the engine bay is engine test, right? Engine test. So there are few engine tests we can actually use, right? There are few engine tests we can use. These engine tests we usually perform as a part of the running repairs. So during the running repairs, if a vehicle came with some problem, then only we will be actually looking into these tests. Before dismantling engine, we do not actually have to do these things because uh, these tests actually give the result for engine to dismantle or not. We get the results for dismantling or not from these tests. So we have engine sound and vibration, cooling system pressure test, emission test, and engine compression test. So engine sound and vibration emission test, those two things are very simple. Anyone can see a emission test report. Engine sound and vibration also, you can usually hear the sound, but you can, I'm pretty sure you can relate to this. Sometimes you might heard some, if you have a vehicle, some parents or some friend or someone, sometimes they say, okay, the engine noise is somewhat different, right? So at that time, something is wrong. So engine vibration is, you can actually feel vibration. Sometimes some people say, okay, engine start, I can actually feel vibration these days, I don't know why. So in such case, you take the vehicle. So uh, in case something is wrong inside the engine, that could also create vibrations. So because of that, engine actually so these tests actually very useful to identify these things. So cooling system pressure test and engine compression test, also two important tests that I will actually explain in the next few sessions, slides. Sorry. Okay, so sounds and vibration. So one of the most common thing that used in the engine testing to understand if there's any problem is sound and vibration. As I told you earlier, if any abnormal vibration or abnormal noise is coming from the engine, or any additional noise or additional vibration is coming from the engine, it could be a reason of a catastrophe, or it could be a it could actually giving out some warning before a catastrophic failure in the future, as shown here. As shown here, sorry, as shown here. So you can see there's like a piston here, right? There's like a piston, not like a piston. There's actually a piston. So uh, I think you are now learning some module, dynamics of mechanical system, or theory of machine, or some module. I think you are learning now this semester. This semester you are learning theory of machines, right? Can anyone answer me? We have a module called theory of machine.
Yes, sir.
So similar module is there, dynamics of mechanical system. In that dynamics of mechanical system also you will be learning this. So the mechanism, the piston movement up and down and converting the sliding movement into a rotational movement, we call it as a, what do you call this thing or this action? This mechanism is called as a sliding crank mechanism, right? Slide crank mechanism. So inside the engine, when slide crank mechanism is working, there are two forces acting. So one major force and one secondary force, right? So how these forces are acting is a little bit odd. So let me try to go. One force, okay, let me draw over here. Major force is acting downwards, while secondary force is actually acting 90 degrees angle from that. Okay, so the reason for this is because of the how the piston is movement. Uh, anyway, because of these two forces, piston is always trying to twist, right? Piston is always trying to twist itself. So in order to stop that, right? In order to stop that, piston has to be a little bit smaller than the cylinder. So that's why piston is a little bit smaller than cylinder, and it also reduces the friction, right? But I think you guys can see here. One second. So you guys can see here, there's like abnormality or something a little bit odd here, right? This is the real color. This is how a piston should actually look like. But you can see there's like a rubbing effect here, right? It looks like this piston has been rubbed on the cylinder bore. This rubbing is actually generated from this secondary force, right? It's actually happening because of the secondary force. It's not ideal. There are so many systems or so many things incorporated in the engine to avoid this, but for some reason it could actually happen. One possible reason is enough engine oil pressure not being reached up to the piston pin. So I'm assuming that you have an idea how engine is working at the moment. So piston pin over here, piston pin, also known as gudgeon pin. So engine oil is actually pressurized and pumped through these connecting rod up to here, right? So over here, it's actually over here, assuming that let's assume that piston pin actually worn out. If the piston pin is worn out, the piston has too much movement. Piston is actually having too much movement to it. So that could end up actually turning the piston, right? Turning the piston on the axis of piston pin. So something, so this is the axis and it could actually turn into something like that. So at that time, piston wall or piston skirt actually started to rub against the piston cylinder wall, which is not ideal. There are few reasons. It could generate vibration. It could it's actually generating vibration. Not could it will generate additional vibrations. In addition to that, this will actually wear out the cylinder wall faster, and it will wear out of one side of the cylinder wall faster. So with the time, this vibration started to increase, right? So these sort of things you can actually find out. Another similar effect, similar thing is the tappet voice, tappet noise. So most vehicles, if the tappet adjustment or valve clearance adjustment, if it is off, then it started to make a noise, right? If the oil is or engine oil is not supplying up to the engine head, right, engine head, then it started to noise. So these sort of things we can actually identify some if there's any wrong inside the engine. So in order to do this, you need to actually have a good experience on the matter, unless it's very hard to do. But still there's a possibility of guessing, and if you know what are the components actually working inside the engine, and what are the components actually what sort of noise is actually making, then it's actually uh, possible for you to actually come up with the basic or come up with the idea which part is wrong. So at the moment we at this stage or at this uh, particular module, you will not be actually doing that. It's a completely different module that completely dedicated for fault diagnostic or fault diagnosis of engines and any other components in the vehicle. So at there you will be able to learn this thing. You will be able to do these things practically. But until then, if you have any more details, you can actually find them through this link I have provided below. Okay, next part is actually cooling system pressure test. This test is actually performed. Basically, this test is performed to find out if there's anything wrong in the cooling system. So cooling system includes radiator, hoses, water pump, and engine block. So there are possibilities. There's a certain small possibility that engine block could actually crack. There could be several reasons for this. one main reason is engine could have driven without water or without coolant. In such case, because of the high temperature, engines tend to actually crack inside the engine block, right, inside the engine block. Or this could happen as a as a as a manufacturing defect also. If there's a manufacturing defect that was never found and later, because of the weakness of the metal, if it started to crack or if it created a small crack or hairline cracks, we usually call this as hairline cracks. In such case, it's impossible to actually find out where is wrong. So in such case, if there's any crack or something like this, it is possible to use engine cooling system pressure test to identify what is wrong. So assuming that a radiator and all the other components is okay, in a such case, if you fix this equipment, this is actually just a small pump where you pump air into the system, where you seal off the system and you pump air into the system up to 15 psi, or the amount of pressure inside the uh, engine cooling system, and wait at least around 15 minutes and see if the pressure is actually dropping. If the pressure started to drop suddenly, that means there is some leak. If radiators also anything is not if any of those are not actually leaking, that means the leak is actually coming from engine block, which confirm there is a crack inside the engine block. So these cracks could actually only open when the engine is hot also. So there are some difficulties finding out where is this. And as you know, engine block is a very intricate one single cast iron or cast aluminum components, which actually is not easy to uh, find if there's any small cracks inside the water channels or inside the engine oil channels. So in such case, there are some other tests we can actually perform in order to find this problem. So we will discuss later on when it comes to the engine overhauling section, because most of the time, if there's any problem inside the engine block, right, if there's any components, any problem inside the engine block, if it is unreachable from outside, there's no way to repair the engine block. In such case, engine block has to be scrapped and find a new one to replace it. So pressure testing procedure is a very simple procedure, which I have, that's why I actually have shared a link in the description over there. So you can go ahead and watch how this test is actually performed for more information. Next part is actually emission test. So I'm pretty sure you are very familiar with the emission test. So emission test is one of the most important tests, even though most people in Sri Lanka is against this. This is a very good indication of about the health of your engine. So basically, in a petrol engine, they check hydrocarbon level and carbon monoxide level. In a diesel engine, they test how much of the NOx level and opacity of the diesel, right? Opacity is how much of polyhydrin is available in the gas or exhaust gas. So in this, uh, if the engine is worn out or if engine is not perfectly working, that means there could be few reasons for an engine to not to perform well. One reason is, so you know that inside the combustion chamber, these are the points where combustion is actually seen from everywhere or everything else. Assuming your fuel mixture or the fuel pressure, amount of fuel coming in, air coming in, everything is okay, ignition and everything is okay. If these 4 points or four areas, actually there's only 3 areas. So 3 areas, because this is a cylinder wall. The bottom one is the cylinder wall. So if these three areas are properly sealed, combustion during the combustion process, it should, right? It should. If it is a petrol engine, it should actually produce very low HC level and low carbon monoxide levels. Similarly, for a diesel engine, it should create a little bit higher NOx value and lower opacity. Okay, but in case these three places are not properly sealed, or either if these three places are worn out, that means these values are going off the chart. So high means something like this. If it is, say, if it is very much near to the particular value provided there, for example, hydrocarbons, the value provided by the emission testing regulations in Sri Lanka is 3. If it is very much close to the, if it is very much close to 3, that means something is wrong in the engine. Right? It means something is wrong in the engine. 3, it should not be actually close to 3. It should be very much lower than that. Right? It should be very much lower than that. Yeah. So these values, some value variation similar to this actually showing that engine is not performing well, so there's something wrong in the inside of the engine. In such case, still you need to confirm where the engine is actually failing from. So as I told you, there are 3 areas that could fail: either intake valve, exhaust valve, or cylinder bore, also known as cylinder piston rings, right? So in such case, we do the compression test. So if these 3 are actually failing, then engine will not have a proper compression inside the engine, inside the combustion chamber, right? So what we do is we fix a pressure tester, or actually pressure gauge, into each cylinder, right? Then shut off the fuel and crank the engine, right? Shut off the fuel or remove the spark plug in a petrol engine and crank the engine. Once you crank the engine, this particular gauge is actually designed to record the maximum pressure, right? Maximum pressure it actually observes. So if these compression or maximum compression values, if they are over 115 and and if they don't have more than 10% variation between them, right, or highest and lowest actually, then engine is healthy, right? If it's not coming up to 110, 115, assume that it's coming up to 110 or something, and the percentage between the maximum and lowest is around, let's say, 12%. In such case, we perform the same test again by adding a small amount of engine oil into the system. So by doing so, we know that's called as a wet test. The previous one is actually known as a dry test. So in the wet test, if the engine is performing well, that means engine is starting to, it's still operational, but it's started to wear out. So that could actually give a even better idea about the engine. But still, right? But still, the problem is actually we don't know whether it's coming, it's still leaking from the top of the engine, or I mean the valve. So is it from the uh, piston rings? So in such case, what we do is we do something called a leak down test. So leak down test is very simple to confirm. What we do is we bring the piston, particular piston, let's say piston number 1, up to the compression stroke. We bring it up to the compression stroke, right? Uh, then we actually put compressed air into the combustion chamber, right? We put compressed air into the combustion chamber, and then we trace where the air leak is. If air is leaking from somewhere, it started to make a hissing noise. By following the noise, we can actually find out where the leak is from. If the noise is coming from the dipstick or from the oil cap, that means the piston rings are actually worn out. If the noise is actually coming from the intake, then your intake valve is not properly sealing. If the air is coming from the exhaust side, that means, or noise is coming from the exhaust side, then it means actually the exhaust valve is not seating there. So with that, you will be able to identify which part is uh, already failed. So I have shared some videos. So this test, you actually perform this test similar to the other test we have decided. This you will be actually performing in the class. So until then, I have shared some links that you can actually go through and find out more about this test. Okay, next we move to the engine overhauling. Right, first thing is what is engine overhauling? So you might have heard this sometimes when someone is trying to buy a used vehicle. They usually try to buy a vehicle that is driven less than 100,000 miles, right? Also known 1 lakh miles. Miles means kilometers. Actually, in Sri Lanka, it's kilometers, 100,000 kilometers. So it's less than 100,000 kilometers. So 100,000 kilometers is uh, actually known as the standard for engine to start wearing out. There's no any scientific data actually supporting this, but all the scientific data or test data is actually showing otherwise. So the reason for this is, as I told you earlier, assuming that engine will start to um, act wear out after that. So it's too much problem after that. Because of it's better to buy a vehicle driven less than that. Uh, anyway, it's not actually the case. Let me give you some examples. So there are vehicles which have even driven more than 10 or 1 million miles, not 1 million kilometers, 1 million miles. So 1 million miles means 16 lakhs 16 lakhs kilometers. So 16 lakhs of kilometers, there are vehicles which have actually driven and still performing well, not 100%, but still performing well. And the tests also shown that there will not be any measurable engine wear up to 100,000 kilometers. Even if you do a proper engine service, if you replace the engine oil and if you replace any other components properly, there will nothing will happen to an engine up to 100%, 100,000 kilometers. So even after that, if the engine is properly maintained, properly engine oil is changed, coolant is changed, if properly maintained, nothing will happen. Anyway, this we can't change how the people are thinking. So there are some reasons for that, because main problem is we don't know whether the engine was or vehicle was properly maintained. So in such case, assuming that your vehicle is engine is started to fail or failed, you have two choices. Number one choice is you can either replace the whole engine, reconditioned engine you can replace, or in some cases you can actually buy brand new engines also. Not something is possible most of the time, but in some countries it's possible to buy brand new engine, not in Sri Lanka. So in some brands still they do, but only for the uh, for that's only for the particular agent only, not others can't buy. So anyway, So in such case, if you come to this issue, at that time you have to decide whether to replace or uh, repairing. So repairing or a full repairing is actually known as an overhauling. Overhauling means you go through all the components and replace all the components with the new. If anything worn out, if anything need to replace, everything will be replaced with new or improved part. So that is actually known as overhaul. So how do you know whether you need an overhaul or not? If there's excessive engine oil consumption, extreme sign of engine needs attention, metal shavings in the engines, or knocking noise. Those are the very common things that you can actually identify whether the engine is actually started to fail. So knocking noise is mentioned here. Knocking noise, there could be two reasons for knocking noise. The number one is what we discussed earlier, piston slap, which actually known as the correct term for rubbing the piston skirt on the cylinder wall is actually known as piston slap. Or it could actually created by something like a crank bearing. So if the crankshaft bearing started to fail, then again start to make a knocking noise. So if such case came to revision, at that time you actually have to go for either overhauling or engine repair replacing. So replacing means you actually have to replace all the engine numbers, and there's like legal uh, obligations with the engine replacement, but engine repairing or overhauling, at that you still use the previous block. In such case, you don't have to actually replace the, you don't have to do any legal works after that. And basically cost wise, these two comes uh, very much similar at the moment. Both are very much similar into petrol engines, but diesel engines, reconditioned engines seems to be a little bit expensive than replacing or sorry, overhauling an engine. So overhauling process. So overhauling process is actually a long process, right? Long process uh, which actually uh, long process which need a lot of attention, lot of equipment, lot of people. So and there's a lot of skill involved in this. Usually these processes were handled by machinists. Machinist is some person who's trained to use a particular machine, something like a lathe machine, a milling machine. But there are specific machines designed to do these particular jobs efficiently. So these machinists are trained to work on these machines for a long time. Usually machinist has to be trained for around 5 years after they completed a technical college training program. Then only they will be actually uh, qualified enough to work on any engine components or something by themselves. So basically this process is, as I told you, very long, and the same process is actually used in when engines are manufactured, right? Same process with small difference, like with a small twist. Same process will be actually used in engine when engine is completely built from the scratch. So I will explain that one in the later. But basically in the overhauling process, first part is assuming that you got an engine. First thing is to dismantle the engine and clean it. You have to clean it very thoroughly because you need to see everything. If there's any problem outside, inside, everything has to be seen. So in this case, most of the time, high pressure washers and ultrasonic cleaners are used as much as possible. So next part is visual inspection, where you actually see any problems, any obvious errors. In some cases, visual inspection actually give very technical data. For example, cylinder wall. So you know that something called a cross hatching is available in a cylinder wall. This cross hatching is there for to retain the retain uh, engine oil layer or layer of engine oil in the cylinder wall after removing the oil from by scraping. scraping ring. So the cross-hatching could not be actually measured, but it has to be inspected visually and come up with, and this should be decided whether it's enough or it's needed to be redone. And after this visual inspection, then the engine is moved into pressure testing mechanism. So pressure testing is actually done. So this pressure testing and the previous pressure testing or the compression testing is quite different. Here what we do is what they do is actually remove all the components from the engine block and the engine head. So you don't have camshaft or crankshaft or anything. Everything will be removed. Only block, only the naked block will be taken out, and it will be covered. It will be properly sealed with transparent sheet and will be put air into them, right? Put air and put the engine into a bath. I will show it later. So what it's going to find in this particular step is if there's any cracks or any problems inside the engine block that could not be seen, right? That could not be seen. So if there's anything like that, the solution is to scrap the engine block if it is not possible to, if it is unreachable, if the block, if the crack is somewhere unreachable area, then there's no solution but to scrap the engine block. So this test has to be done in the beginning, because after doing it, there's nothing you can actually do afterwards, right? There's nothing you can do afterward, because there's no point of doing this test after everything, because if there's any cracks or something, you need to know beforehand. So next, we can actually, so these uh, next few steps could actually change. It doesn't matter which one you are starting from, based on the uh, required work, it could actually change. So next we have engine block surface grinding. So surface grinding is used to remove a small layer of material from any surface. The purpose of this surface grinding is to make sure engine surface or engine decks, engine surface grinding, also known as deck grinding. So cleaning the engine deck and making sure that engine deck and the head deck is actually straight, and 100% contact could be achievable, at or achieving the contact as much as possible when block and head is in contact. So the sealing or seal the surface properly. So these two contact surfaces has to be sealed well. Next part is you move into the cylinder boring. So cylinder boring actually have to be done in a manner. Uh, so what happened here is, once engine is dismantled, then the engine actually have to be measured. So cylinder wall has to be measured. So once you measure the cylinder wall, right? Once cylinder wall is measured, right? If it is off, or if it cannot be rebored, then you have to put a new cylinder liner. And rebore it up to the proper specifications, right? So how do you usually identify if there's any wear or something in the engine? By visually, or at least by touching, is there's something like this. So usually we draw, sorry, if someone asks you to show a cross section of the cylinder wall, we show something like this, right? But there's something called TDC and another something called BDC, right? So piston is actually moving in between these two. So piston is actually moving in between these two. So if the piston is moving in between these two, that means the maximum point, right? Maximum point piston is reaching up to here, right? Beyond TDC, it will not go anywhere. So wearing, engine wear could only occur between these two areas. So between TDC and BTC only wear is actually occurring. So that means that's too big, but you get the idea now. It's too big. Inside the combustion, inside the compression volume, right? Inside the compression volume, the diameter of the cylinder is the actual or the correct specified cylinder diameter. So if engine worn out, if the engine is worn out, that means, sorry, when you actually put your finger, if you can feel a lip, like this because of the worn, so I'm drawing like an exaggerated view here. So you should actually feel like a small step there. If you can actually feel a step, right? If you can actually feel a step, that means engine is actually worn out. If it is actually less than 0.25 millimeters, then it's actually possible to rebore it, right? It can be rebored up to 0.25 specification, so that's called as a it's actually called as a repair size, and replace with the repair size components. So after doing this, now since you reboard or resurface the cylinder wall, now cylinder wall needs something called honing. The purpose of the honing is reinstate the cross hatching. As I told you earlier, cross hatching is actually used for retaining the engine oil. Next one is, after doing this, we go to the crank race line boring. So line boring is a process that we use to make sure that crankcase or the main journals, in this case, main journals are straight and aligned to each other, and we bore them up to the correct specification and make them align together before we put the before you put back the crankshafts again. So by doing so, we make sure that the crankshaft can actually rotate freely without any problem. Next, we replace the water pump and oil pump refurbishing. So if these components are worn out, then you actually have to replace them. So how to test whether these are actually, how to test
Mm-hmm.
So who is there?
ගන්න හේතුව ඉතින් අර ගම්මාත පිටා වෙන්න කතා කරන්න ඕනේ. ඔව්.
Someone's mic is on. Can you please switch it off? Okay. Seems switched off. Okay, so afterward, crankshaft will be inspected. So crankshaft inspection is quite a odd task. Usually you have to find out if there's any cracks or any damages inside the crankshaft. As you know, there's a oil channel going inside the crankshaft, so make sure that nothing is cracked or if there's any small cracks inside, because the crankshaft is actually taking a huge amount of pressure from the cylinders. So if there's any small crack, it could actually create a catastrophic problem later. To avoid that, you have to actually check them before. So if the engine is fully disassembled, at that time you have to check the crankshaft. For you have to inspect the crankshaft. So afterwards, you can go for crankshaft grinding and balancing. In this also, you have to go ahead and do it in a pattern or in a way that you can actually repair them. So grinding means you can actually reduce the diameter of the journals up to a certain point in 0.25 increments, then replace the journals with the repair size. We are calling these as repair size, repair size bearings, right? Connecting rod also has to be aligning in the same way, because connecting rod alignment is a very important thing because of the twisting loads generated inside the combustion chamber. Connecting rods tend to twist, and this is actually working under higher temperature, so it could actually twist. In such case, it has to be made sure that the big end journal center and the small end journal center is actually aligned, not twisted or anything. So in these things has to be checked, tested, and fixed. Next, engine head has to be dismantled. Head has to replaced, resurfaced, and it also has to go through the pressure testing step. Then valve guides has to be replaced. Valve guide is where the valve is actually moving up and down, so it's actually a lubricated component. So lubricated components that need replacing if they are worn out. So if the engine is actually dismantling, it's always advisable to replace them, because these are very cheap components. Again, valve seats also has to be replaced because of the heat cycles. Usually valve seats are usually failing. So valve seats has been a big topic recently in the automotive industry, mainly because of the BMW and BMW engines. Actually, BMW engines usually had a very big issue with the valve seats, because their valve seats started to failing. And the valve seats failing means all the components on top of the engine has to be removed, and just to replace just small rubber seal, right? So that's one additional information. Then valve has to be replaced, and valve seats has to be replaced and resurfaced to make sure that the valve is seating properly, to surely completely seal the combustion chamber. Similarly to the earlier, then you have to go through the camshaft journals has to be regrind, right? Camshaft journals has to be regrind, but somewhat different to the crankshaft. You could not, and you could not touch the camshaft. Camshaft is also in a high, always under a lot of stress. And the other thing is just changing a small, like a very small thing, even like 0.025 millimeters of camshaft could actually affect the engine, because camshaft is the one single component that could actually affect the whole performance of the engine. So by just changing the camshaft, engine can be changed from a normal street driving vehicle up to a racing car driving or race car engine, because cam lobe starts the crank lobe shape that really affect the engine performance and the characteristics. So after that, reassembling the engine head and engine block, finally you put those two together and assemble the engine. Okay, so since that's the basic process, in that process, these are the, so as we discussed, I think you noticed that some processes are actually doing it again and again. So for example, line boring is done for engine head as well as for uh, engine head as well as for engine block. So now we will be discussing similar things like that. I told you the first thing is to visually inspect. So visually inspection, first part is actually uh, wear marks. So scuff marks or metal to metal contact points are not ideal for a vehicle. So first thing is to check if there's anything like that and make sure if there's anything like that, it has to be resurfaced and fix it back or completely replace the component. So uh, yeah, so in the first image, as you can see my cursor, so this is actually known as cross hatching. Cross hatching is as you can see, it's actually like a cross hatch sort of a pattern. So this pattern helps retaining the engine oil inside the combustion chamber. So if this cross hatch pattern is not there, that means it's worn out. It's always should be visible. And if there's any rubbing, if there's any rubbing or piston slap, in such case the cylinder wall will actually look something like this, right? Cylinder wall actually will look something like this. In such case, cylinder has to be replaced, or based on the condition of the cylinder, I'm not exactly sure how to explain this. If the cylinder can be salvaged, or cylinder it can be resurfaced and reboard and cross hatch, then there's no problem of doing that. If it is not possible, it has to be replaced. And the second thing, mostly concerned thing, is carbon buildup. So carbon buildups actually give one very good idea why, what is the problem in the engine. So the image here, right, image here, as you can see, this is actually a combustion chamber, actually a head, head and the upper part of the, or the roof of the combustion chamber. So you can see actually there's a carbon buildup inside over here with the black color, but this is not a problem. Carbon should be there. The carbon is not there, that's a problem, right? And in a, and but if you see this poppet valve, it's called as a poppet valve. So in this poppet valve, you can see there's something marked here, right? It's actually circle here. So this circle, you can see some carbon is actually there and it's looking wet. The reason for this is, that means if this is wet and if there's carbon buildup over here, the reason for, only reason for this is the engine valve guides are already worn out. The oil is actually dripping through the valve guide, or valve seals are failing. So in such case, oil is actually coming here and oil is actually coming up to here. The carbon or the exhaust gas or intake with all the dirt and everything is actually uh, coming and building up here. So these sort of things are not ideal. In addition to this, if you look at here, if you look at over here, you can see that ring, this poppet valve, this surface ring is where it actually has to be completely sealed against the cylinder, sorry, valve seat. But you can see there's like a small small sort of like a marks here, right? More sort of a marks here. The reason for these marks to be there is, if there's like any mark sort of thing, that means the cylinder piston or valve is actually not properly seating against the cylinder, against the uh, valve seat, right? So these are not ideal. So in such case, you actually have to replace those resurface. I'm not exactly, I can't exactly say what has to be do. Based on the situation, you have to examine and see if it is worn out, then has to be replaced. But at this instant, it seems like it has the cylinder, sorry, valve seat has to be completely replaced. And third one is hot spot. So inside the engine, each and every component is properly cooled. It's designed every part to be properly cooled. But so that means engines, one section of the engine should not actually have too much heat build up in here. So the shown image, the third one or the bottom image, is actually, you can see like a some odd brown color, right? This is odd brown color. This is actually generated because of the this is not actually oil. This is because of the reason for this is aluminum pistons started to burn. So this is sort of like a aluminum or change of the engine, change of the piston due to high heat concentration, right? High heat concentration on these areas end up actually creating different colors like this. So these are not actually ideal. So every part is actually properly cooled. This piston skirt is supposed to be cooled from the engine oil squirting, engine oil coming from the bottom of the cylinder, right? The engine actually, the squashing engine oil from the bottom of the engine is actually supposed to cool this section, and the piston pin is actually getting engine oil through the connecting rod. So all of these engine oil, which actually has to be going around it and supposed to cool all these components. But if it is not happening properly, these could actually end up something like this, and may even cause even further damage later on. So these sort of things are not properly proper things, and if this is present, the reason could for this could be somewhere else. For example, in this case, oil pressure may not be enough. That means oil pump may be actually failing, or the oil pickup, or the strainer may be actually clogged up. Whole oil system or the filter may be having some issues, or the filter may be old. So in such case, the whole engine rebuilding actually makes sense. So visual inspection, again, very important. Okay, so now we move into the pressure testing. So as I told you earlier, the pressure testing is an important matter. So there's the second image. If you move your, sorry, if you move your attention to the second image, you can see, can you see there's like a small crack? There's a small crack, it's almost invisible. So these sort of cracks is not visible from outside. So this is a little bit, at least a little bit visible. Sometimes these sort of cracks could actually generate inside somewhere like oil parts. So in such case, it's impossible to find these. What we do is we use a equipment like this. This is actually a pressure tester. So what we do is we clamp our engine block. Let's take engine block from top and bottom, right? We close all the inlets and outlets. Then we apply pressure into it and put the whole unit into a water bath, right? That water bath is actually heated water bath. So, and we include, as I told you earlier, we introduce pressure into the sealed engine block, right? If it started to bubbles started to come out, that means somewhere there's a leak, right? Somewhere is a leak. So if the bubble is coming, that means engine block is actually failing. So, and the reason for putting into a water bath is actually it's a heated bath. The idea of the heated bath is, since the engine is actually working in a higher temperature, around 99 degrees temperature, these sort of cracks could actually expand and open at higher temperature. So in order to see that, these water baths are temperature controlled, so you can actually adjust the temperature up to the necessary limit. So this is something it's actually doing. We can't do it. We don't have these equipment in the workshop. It does not actually make any sense to have these in workshop or our classrooms, because these are commercial equipments. We are only using for one practical means. It does not make any sense. But usually what we do is, if we have time, we take you guys to a engine rebuilding or overhauling workshop just to show these things. But until then, because I'm not exactly sure whether we can do it or not, so I found you the next best solution, which is actually pressure testing procedure through YouTube. So there are two tutorials I actually tutorial videos I actually linked here. You can go ahead and watch them and get an idea about how this actually works. Next one is actually surface grinding. So surface grinding or deck grinding. So deck, again, why is it called as deck grinding? The reason for calling it as the reason to call it as the deck grinding is this particular surface, right, or the top of the engine block is actually called as the engine deck. This is one important part of an engine block. This engine deck uh, sometimes provide engines. So contact with each other well. So both surfaces has to be very straight. So how do we do it? Is we, after dismantling, usually put a straight edge on top of the engine deck, and if the straight edge is not properly seating, if the straight edge is not properly seating on the engine deck or the head deck, that means it's need actually attention. So resurfacing has to be done. After testing the surface in the straight edge, this has to be done. So this is a for this particular application, the equipment used is actually surface grinder. Surface grinder is a common equipment used compared to the previous equipment. This is a common equipment used for surfacing any metal surface. It does not design just to do this particular operation. So same process is actually done for the engine. Uh, Same process is actually done for the engine head as well. So head surface or the bottom surface of the head also has to be properly surfaced, resurfaced, and make sure that it's straight as an arrow before they are put in back together. So one more thing, when I was discussing earlier about the process, how the steps are going on, my engine surface grinding was before engine cylinder reboring. But if you are replacing the cylinders, right? If you are replacing the cylinder, then engine in that case, engine surface grinding will actually happen after replacing the engine. So after replacing the cylinders and doing the uh, after doing the reboring work. So cylinder boring is the next topic. So cylinder boring usually done in order to fix the cylinder size up to the correct specification. So if it is it's usually done in 0.25 millimeter increments. So what do you mean, what I mean by that, if the engine is actually, if the cylinder uh, cross hatch actually has been gone out. In such case, what we do is, if the cylinder started worn out, it started to wear out, what we do is we increase the diameter of the cylinder wall by 0.25 millimeters, right? Then we do the cross hatching again, also known as honing again, and put new piston and uh, new piston rings, then use it as a brand new engine. So this cutting work or this reboring works were done in 0.25 millimeter increments. Also 0.25 millimeter increments, it can be done for 3 times maximum. That means up to 0.75 millimeters can be done. So afterwards, if it is done for 3 times, then cylinder line has to be replaced, because beyond that point, cylinder wall is, or cylinder liner is not actually strength enough. But in modern vehicles, so this is very simple process for cast iron engine block, but nowadays aluminum Engine blocks are mostly used in most vehicles to reduce the weight. In such case, cylinder liner replacement is not an option at the moment because cylinder liner is actually cast into the aluminum block, so it cannot be removed. So it has could not be replaced because of that. So yeah, once piston engine board, the piston engine rings need to be replaced with the appropriate repair size. So again, tutorials and videos how the process is going on is actually shown or shared here. And the machine actually used is actually known as a reboring machine. It's only used for reboring, but there are machines which comes together with the honing equipment as well. This is somewhat like a milling machine. Milling machine can be actually retrofit to work as a boring machine. So next part is cylinder hatching, also known as actually honing. So cross hatch. So cross hatch, as I told you earlier, is very important. So again, after reboring, it cross hatching has to be uh, re-established. So cross hatching for different vehicles, different specifications are there. It's starting from like 30 to 40 degrees angle up to around 70 degrees angle is the maximum it goes between two hatches. So there's a hatching actually machine is available, but in addition to that, it can be even done at home using a hand drill similar to shown or similar to this, but it needs a lot of skill. Still, the in order to do it properly, still you have to use the correct machine. So since I have talked about this one so many times, I'm not going to actually go through it again just to explain how the cross hatching actually works, but I actually hope you will go through and find out more details about what is honing and why cross hatching is available in the engine blocks or cylinder walls at least. Line boring. So line boring is, as I told you earlier, this process is trying to make sure that the crankshaft or camshaft can properly or freely rotate and there's no alignment, misalignments or something because of the high temperature and high load is actually actuating or it's actually working on. So how it works is, as you can see or in the image, actually you can see in the bottom image, there's something like a shaft is going. So usually how it works is you remove all the components and put all the journal caps back in, right? Journal caps back in. So the main journals caps will be fixed back and they will be talked into the specifications. Then the machine it will be placed in the machine. So this machine is actually a line boring machine. So it uses a special cutting tool, cutting this sort of the tool sort of thing. It's actually known as a boring bar. So this shaft, this particular bar is actually known as boring bar. So you can see like small holes and small rounds sort of things are there. These are actually cutting. So abrasive cutting points. So while this is actually rotating, right? When it is actually rotating, right? It uh, cuts and remove if necessary. It can actually remove a certain amount of uh, material from these journals, but if they have any misalignments while it's rotating, it's actually fixed. So this is the problem here is I'm just giving you a basic idea how this process is going on. If you need to learn this, this is a huge process because it's like a rebuilding a complete engine from the scratch. Hopefully you understand what I'm going through, what I'm actually explaining you through. So for more details, I actually again suggest you to go through these videos because they will explain it properly with the equipment and how each component is actually working. So next part is actually crankshaft. So crankshaft, first you have to test. So there are two tests you can actually do. One thing is actually doing a most common one I have seen in Sri Lanka is doing a tapping test. So second one is ultrasonics testing, where you actually do send the ultrasonic signal through the crankshaft in order to find out if there's any cracks. But ultrasonic testing is very expensive and very advanced testing method. It can even say where is the problem and what is the issue. The tapping test is compared to that, tapping test is a very simple test. What it does is you fix the, or you put the crankshaft in a fixture which allow it to freely rotate, and you tap it with a small metal rod. So once you tap it, since this is a single cast component, it actually should create a noise. A very simple tone is coming from this casted component. So it's actually should come as a single tone. But if it is coming like two tones, right? If it is two tones are coming from it, then it means it's actually having a problem. That means it's actually having a crack inside. So in such case, we actually have to replace the crankshaft. So, and I have seen this. Some people are doing, some mechanicians are doing, and they are very experienced on the case. Not unfortunately. So, I am having hard time actually explaining more than this about this topic. So more details you can actually find out through this link. It should that line boring topic has to be changed. I will fix that. uh okay, there's a small error. So this crankshaft sorry, crankshaft regrinding and balancing slide. So here the crankshaft main journals and small end journals will be actually grinded and resurfaced. Unfortunately, I have not put the correct photos into that. I replaced the photo from the previous slide. So basically, in this, I will fix this, and I will when I'm uploading. Well, I already uploaded, but I will fix it back. So I will put a new slide, set of slides. So if you have already downloaded, please make sure to download it again because of this issue. So yeah, here the what happened is crankshaft regrinding. So crankshaft is if crankshaft is also having scratching mark or uh, bolt metal to metal surface contact marks, in such case crankshaft actually have to resurface. So crankshaft journals has to be resurfaced. When journals resurfacing, it has to be resurfaced up to the correct standards again. So usually it also goes by 0.25 millimeter steps maximum, right? So it can be done, and it is when it's actually after the resurfacing, then you actually have to replace the whole thing with after replacing it, you actually have to bearings has to also replace with the correct repair size. So regrinding again, information is actually shared for you to watch. Okay, so bearing, sorry, connecting rod, as I told you earlier, one main thing is making sure this point and the center of this point, right, of big end and the small end centers are aligned together. So in order to make sure that you have a equipment like this is making sure that it's actually properly aligned. And in addition to that, you can see there's like a bearing here. This is actually a bush bearing which use oil to proper oil lubrication. So if this is also having any surface to surface metal metal surface rubbing against them, this has to be replaced. So it's actually brass bearing. You can, by hydraulic pressure, you can actually remove it and fix a new one. After fixing, again, this has to be rebored up to the correct specifications, because just directly using is not possible, right? So videos shared here, videos and other, yeah, some details shown here. You can actually go ahead, and in addition to that, something called balancing is also there. This is not what we not something we do for usual engines. If we are going for like a if you are going for like a performance build, we usually do that. I will give you a small explanation about that later. Next one is resurfacing, sorry, replacing the valve seats. So as I told you earlier, valve seats has to be properly fixed, and they supposed to be well in contact with the each surface. So to make sure you, I know you guys know this process very well. You have been doing this in the for your A-level examinations and practical exams as well. So I don't think this is something I have to explain again and again. So seat replacing, usually what we do is we heat the valves. So when we heat it, because of the temperature difference between the valve and the body head block, the valve seat usually pop out. Then remove it, replace with a new one, and we cut the angle up to the surface angle. We have to first cut using a valve seat cutter, which is shown in the first image, which cut up to 45 degrees angle. Then replace it with a new valve. Then use valve grinding paste and grind it until they are properly seat together. So the process is actually shown in the image. So up to here only I am actually planning to discuss today. So this is the process in the engine rebuilding, and yeah, so one additional thing I would like to discuss is something called the engine engine blueprinting, right? I will give like a very simple explanation for this. It's not possible for me to give like a big explanation. It's out from this topic also. Okay, so uh, right. So if we take an engine, you have few parts. So piston is moving this way, and this is the connecting rod and the crankshaft. Okay, so that's the crank rod. This one is crank rod. Anyway, so piston is moving up and down, right? And when the piston is actually moving up and down, the weight of the piston, right? Weight of the piston, let's say this is mg. So mg is the weight of the piston, so it's going up and down. So this weight is actually creating a inertia force, right? This weight is actually creating an inertia force. Let's take the connecting rod. Let's say that is that's also m something g. Say mg1, right? So connecting rod is also moving. So all these component moving, right? And when these are moving, it's actually creating a force against the compression, or a force against uh, what actually generated by the engine itself. That means the combustion pressure. So, and in addition to that, if you have 4 cylinders, all 4 cylinders are not going to be at the same weight, and the cylinder similarly, the connecting rod is also not going to be in the same weight. Each components have different weights, and there's a small difference. Because when we manufacture some components, because of the mass manufacturing, it's impossible to make sure that each and every component is up to the correct standard. So, if when we are designing engine, if we design the engine cylinder to be 20 grams, right? If this is 20 grams, not 20 grams, 200 grams, right? Let's assume cylinder has to be 200 grams. Sorry, piston has to be 200 gram, but it's could be even 210 grams, or it could be 190 grams. Okay, 190 grams. So if there are 4 cylinders, right? 4 cylinders, 4 piston, each piston is different weight. So different weight, different inertia forces. So different main force is actually acting. So as a result of that, once engine is completely built and fixed, and if we measure the output, so we can go. Sorry. And the forces from the first cylinder, let's say this is 200 mg, right? It could come like this, that how it's actually generating force. But the second cylinder, right? Let's say this is starting somewhere here. This is 210, so it generates higher inertia force. So higher inertia force means less force is generated, right? Third one is even higher, less weight. So less weight means go for so once we combine all of this, the final outcome, or the final power outcome, is actually coming something like this. Right? It's not smooth. So in order to make them smooth, we have to make sure every component is having the same dimensions, same parameters, same weight. So blueprinting is doing that. So what we do is, if a piston is like, I'm taking a piston because it's the simplest example. So if we take a piston, we take 4 pistons and we weight each piston, right? We weight each piston. So if one piston came 200 and other one is 210, other one is 209, 190, then what we do is, right? We have two choices in such case. Let's say 210 all came like 210, 210 and 200, right? So the specific weight, the actual weight, the blueprint or the engine specification says the weight actually has to be 200 weight. It's designed for 200 weight pistons. So what we do is we take all three and reduce up to 300 grams. 1 second. not 300 gram, 200 grams. So what we do is we reduce all weight of all the cylinders. So cylinder 1, 2, and 3, and 4. All 4 has to be reduced up to 200 weight. So doing this for each and every component and making sure all are perfectly matched to the blueprint or the specifications given for the engine design specification is actually known as blueprint, right? So that's actually done for only high performance vehicles. We usually don't do it for other vehicles because this variation in the power is you can't actually measure it, but in such case these RPM changes, very small changes even can be noticeable. So we go back. Yeah, so these are the processes. In addition to that, we usually do other works in these engine components. For example, if it is possible to reduce the weight over in this 1 second. If it is possible to reduce the weight of these components, in such cases we reduce, because in order to reduce the inertia. So if we reduce the inertia, engine performance will increase, and oversizing the piston will actually increase the engine capacity and it will generate more power. In high performance applications, these are very important, even though they are illegal. If it is possible to do, most guys are actually doing it. Another one change I can actually I can talk to you is let me go and see. We have a cylinder. Oh yeah. So another small change that do for high performance vehicles is this channels, so runners up to the valve. So these runners are actually, since these are casted components, they are actually very rough. So this rough surface is increasing turbulence, which is not ideal for a full injected vehicle until it comes up to the combustion chamber. It should not be actually turbulent. So after coming inside only, it has to generate turbulence. So over there, turbulence is reducing the pressure and reducing the amount of air coming inside. So to avoid that, this whole opening will be completely resurfaced and remove any ripples or any rough surfaces, right? So these sort of things are doing in order to get, and by doing this sort of a small work can actually get around 5 to 20 horsepower out of a normal engine. Okay, that's it about the engine block and all this engine rebuilding. And make sure you go through all of these things, because uh, the reason is you have a group assignment. So group assignment, it's a internal combustion engine overhauling. So what you need to do is prepare a presentation that explain step-by-step process of engine rebuilding and proper and improper practices. For proper and improper practices means, for example, so if a crankshaft is regrinding, all journals has to be regrind to the same value, same number of, so same diameter. You can't uh, grind one German higher, one journal higher than the other. So you can't do such things. So everything has to be done perfectly. So that sort of things explain and discuss. So this is a group assignment, and you have 15 minutes. Due date is 29. So you have around 3 weeks to submit this. So submission is, there are two submissions here. You have to submit like a PDF copy uh, and the presentation itself, and you have to keep it yourself also, and you have to present it on 2nd of June 2021. That means next month. So that means it's a Friday. So 5 groups, I expect 5 groups. So you have 30 students, right? Anyone? According to the attendance sheets I have, we have 30 students. So I need you guys to answer to this. Either I can actually assign you to groups, or you guys are allowed to divide into groups. So which one you prefer? Whether you guys want to get into groups, or should I assign you groups? No answer. Okay, that means I am assigning you to groups. Came in the you guys can't unmute. Maybe. Can't unmute. Oh, our mics. Okay. Let me check. Okay, now I think you can answer. So should I divide you into groups, or will you be dividing yourself into groups? Whereas mic is on.
Sir,
Yeah.
you divide.
Okay, I have divided. Okay, then I will be dividing. And I will, well, I will be dividing according to the index numbers. Oh, sorry, registration numbers. So I will divide, and I will send you the group list. So based on that, work and submit this. So again, don't submit in the, please don't submit through emails. If you are submitting, if you don't have the LMS accounts, in such case I am having a little bit difficulty. So either one of your groups can upload in that case. So group assignment, yeah, so you have 3 weeks. I think that's more than enough weeks. You have to submit by 29 a PDF document, and your actual PDF document is enough for me to submit. You guys can only submit the PDF document. Presentation is on 2nd of June, so I will be marking both of them. Yeah, so make sure to do that.
So is that 2nd of July, sir?
Oh, sorry, 2nd of July. Yeah, it's 2nd of July. Yeah. So next class, we'll just go ahead and discuss about engine assembling and workshop manuals, and we'll start the next section. So this is the assignment for this section, right? So you know that there's like sections of one sections of class. So earlier you introduction, now we're talking about the engines. So this is the assignment for this part. In addition to that, to make sure that you are up to speed and you are going ahead with the videos or lectures or everything, I have uploaded a quiz. So all of you have to actually answer the quiz. So there are some students who still does not have the, or having trouble in the LMS. So I will send them the email. I will send them an email. So answer to send me back through email. So when you are answering, postcode space quiz one. That's it. Don't write anything else. right? Put your index number and everything registration number and everything in your answer script. Don't put anywhere else on the answer script and send it back to me. Then I'll mark and I'll get back to you. So yeah, I got the first assignment, so I'll mark and I will send you the marks ASAP. Okay. Yeah, that's it. If you guys don't have any other questions, good night. Thank you very much for participating. Kevin, there's yes, already uploaded. There's a small error in this. 2 photos or something has to be changed. So after that, I will upload the new one. So everything is uploaded to LMS, right? So all the things are in the LMS. So before I start the class, I always upload this one to LMS. So make sure you check. Okay, thank you. Good night.